Assalamu alaikum students. The topic that we'll be doing today is sequences. Uh, let's just go through some basic number patterns. This topic is more about observations, understanding patterns rather than complicated calculations. So first, let's go through some very basic patterns. I'll write a few patterns and let's see if we can recognize them. If I'm writing down 2, 4, 6, 8, 10, and so on. Yes, so what do you observe in this pattern? Yes, there is a difference of 2 in every other number, or we can call it in even numbers. We can call all of these even numbers too. Now let me give you another pattern: 1, 3, 5, 7, 9, and so on. Again, this is another pattern. We call them odd numbers. The difference is consistent. It's still 2. Let me give you another pattern. 2, -3, -8, and so on. Now, is this another pattern? Yes, it is. You can see that the difference in all these consecutive numbers is of -5. So these are a few patterns. All these patterns, these specific ones in which the difference is constant between two consecutive terms, are called arithmetic sequences or arithmetic series or arithmetic patterns. What are arithmetic patterns? In which the difference between two consecutive terms is the same. Those are called arithmetic sequences. So let's understand how do we model arithmetic sequence first before going on for the future, before going on to the next terms. अच्छा, सबसे पहले let's see कि what do we do. हम कहते हैं let's call the first term t1 and let me call that a. And then the other parameter that it has is d, which is the difference or the common difference. How do we find common difference? We can subtract any two consecutive terms. We can take the preceding term. For example, I take t2 and I subtract t1 from it. And I can get my difference between two consecutive terms, which is constant or common in all, in any of the arithmetic sequence. ठीक है? तो जैसे फर्स्ट में डिफरेंस 2 है, the second one it also has a difference 2, third one has a difference of -5, but the difference between two consecutive terms is the same. If it's 2, it stays 2. If it is -5, it will stay -5. Okay, so another way of writing down difference is if I take tn, if I'm calling tn का मतलब होता है any term, generalizing any term with rank n, so I'm calling it tn, and I subtract the previous term, which will be n-1 from there. Example इसके ले सकते हैं कि अगर कोई कहे third term minus second term, yes, even that is possible. Fifth term minus fourth term, even that is possible. तो इसको generalize कैसे करेंगे? We'll say कोई भी term, take any term, let me call that rank n, and the term before that one, तो n-1th term हो जाता है. तो this is just a general way of writing it down. Okay, once we have these two parameters, how do we find the second term? We take the first term and we add the common difference in that. Let's take the example of this. इसमें a first term is 2 and इसमें difference is also 2. So if I were to find the second term in this, I'll say that will be a plus d, which is 2 plus 2 and hence 4. Let's have a look at this one. So इसमें a is 1 and d is 2. So if I were to find the second term, I'll say a plus d, which is 1 plus 2, and hence the second term is 3. इसमें a is 2 and d is -5. So if I were to find the second term, I'll say a plus d, which is 2 plus -5, which is -3. So that is how we can find the second term. What about the third term? The third term can be found by taking the second term and adding the difference in that. In place of the second term, I can write a plus d. So the third term becomes a plus d, which is a plus 2d. Remember, I'm specifically talking about an arithmetic sequence in this one. It is a sequence in which the difference is constant or the difference is consistent. So if I were to find the third term, I'll say a plus 2d. The third term a is 2 and plus 2 times 2. So the third term is, the third term is 6. Similarly, you can do a plus 2d in this one as well. A is 1, 2, and difference is also 2. So that will make it 5. In this one, the third term is a is 2. 2 times difference is -5. And minus 10 plus 2 is minus 8. So what is the pattern that we see? If I'm talking about the second term, I'm adding the difference once. I'm talking about the third term, I'm adding the difference twice. So if I'm talking about the fourth term, we can observe the trend that it is a plus 3d. इसी तरह if I am talking about the fifth term, that is a plus 4d. If I am talking about the 12th term, that is a plus 11d. If I'm talking about nth term, which is generalizing it any particular term, that is a plus n minus 1 into d. So let's take an example over here. If I tell you to find the 12th term in this, you will say that is a plus 11d. Your a is 2. Your difference is also 2. So that will be 2 plus 22 is 24 is the 12th even number. If I tell you to find the 14th odd number, that is a is 1 plus 13, d is 2, so 26 plus 1 is 27. Similarly, if I tell you to find the 7th number of the sequence above, a plus 6d, your a is 2 plus 6 times the difference, which is minus 5. So your 7th term of this sequence will be 2 plus 2 minus 30, and that will be minus 28. So this is how we can figure out any particular term for an arithmetic sequence. Now let's understand a few more basic number patterns which are not arithmetic. So if I give you 1, 4, 9, 16, and so on, what do you recognize about this? The difference is not consistent. Yes, it's not. But what do you see? All of these are square numbers. So if I were to find the first term, I'll say that will be a square of 1. If I were to find the second term, that would have been square of 2. If I wanted to find the third term, that will be square of 3. If I wanted to find the seventh term, that will be square of 7. Similarly, if I wanted to find the nth term, that will just be n square. Then let's see another terms: 1, 8, 27, 64, and so on. Again, the difference is not consistent. We cannot categorize it as an arithmetic sequence. So if I were to find the first term, you can see that all of these are cube numbers now. That will be cube of 1. The second term will be a cube of 2. The third term will be a cube of 3. Similarly, if I wanted to find the 8th term, that will be a cube of 8. And if I wanted to find the nth term, that will be a cube of n. Let's look at another common example. 1, 2, 4, 8, 16, and so on. Well, let's simplify it. It's not right one. Okay, now what do you see in this one as well? These are neither square numbers, not cube numbers. But yes, they are powers. They're changing the powers of 2. If I wanted to rewrite it, I can write it as 2, 2 square, 2 cube, 2 to the power 4, and so on. So if I wanted to find the first term in this, that would have been 2 to the power 1. The second term will be 2 to the power 2. The third term will be 2 to the power 3. And the nth term will be 2 to the power n. Okay, so now let's move on to quadratic sequences. Let's write a few numbers, 2, 6, and then 12, and then 21. Okay, so what trend do you see in this? The difference between the first two terms is 4, and then the difference between the next two terms is 6, and then the difference is 8. So the difference are not consistent. We cannot call it an arithmetic sequence, but yes, the difference of the difference, which we call the second difference, that is the same. And that is what we call a quadratic sequence. Okay, how are you supposed to think when you encounter a quadratic sequence? You are supposed to think in multiples. That will help you conclude the quadratic sequence. I will go to the general formula as well, but you're supposed to think in multiples. Okay, how are you supposed to think? You're supposed to think that the first term is 2. Now the rank is 1, but the number is 2. How do I get 1 from 2? You're supposed to think in multiples, okay? What multiplicative operation should I use with the number 1 to get 2? You can just simply multiply 1 by 2. Then the second term is 6. Now the rank is 2, but the number is 6. What multiplicative operation should I use with the number 2 to get 6? With 2, you said 1 should be multiplied by 2. And this one, 2 should be multiplied by 3. And the third term is 12. And this can be obtained by taking 3 and multiplying it by 4. Similarly, if I were to get the eighth term of this sequence, I'll simply take 8 and I'll multiply it by the number right after that one, which is 9, and that will be 72. So if I were to get the nth term, I'll just take the number n and I'll multiply it by the number right after that one. So this is, these are quadratic sequences or quadratic terms. We'll go to the general formula as well, but just to give you very basic info of the quadratic sequence. Okay, let's have a look at this pattern. These are called triangular numbers. 1, 3, 6, 10. For example, the bowling pins that you arrange, this is how you arrange. And if you continue arranging it in that way, these are the numbers that you can get: 1, 3, 6, 10, 15, and so on. Now, if I tell you to make a sequence for this one, this is initially, it looks a bit tricky, but trust me, it's an easy one. Okay, try to link it with the one that we have just done, which is a very basic quadratic sequence. 2, for the sequence that we did was 2, 6, 12, and 20. Observe now, 2, if I divide that by 2, I get 1. 6, if I divide that by 2, I get 3. 12, if I divide that by 2, I get 6. 20, if I divide that by 2, I get 10. So if I were to find for triangular numbers, if I were to find the first term, I'll say I'll just take the previous one, and I'll divide that by 2. The second one, I'll take my 6 and I'll divide that by 2. So if I were to get the nth one, I'll say I'll take n, I'll multiply it by n plus 1, and I'll divide that by 2. Or I can also write it as half n into n plus 1. Both mean the same thing. So this is one way of understanding very basic quadratic sequence or specifically triangular numbers. Okay, another, let's generalize the quadratic sequence as well. Okay, let me write very basic formula for a quadratic sequence, that is a n square plus bn plus c for any quadratic sequence. And when do we get a quadratic sequence? When we have a difference which is changing by the same difference for every number. So if I were to find the first term, let's plug in n as 1 and I'll get a plus b plus c. If I were to find the second term, I'll get 4a plus 2b plus c. If I were to find the third term, I'll get 9a plus 3b plus c. Now let's talk about the first difference. What is the first difference? The difference between two consecutive terms. Okay, let's have a look at D1. First difference between the first two terms. This guy se nahi likhte hain. Let's see. Let's change the pattern. Okay, so I just simplified it. An square plus bn plus c. So when we plugged in the first term that we got was a plus b plus c. And when we plugged in n as 2, we got the second term, which was 4a plus 2b plus c. Remember, the ultimate objective of this entire drill is to help you understand that you need to form a link between the rank and the number that is existing on that rank. So you need to create a basic formula for a term in which you can just plug in the rank and get the number that exists on that rank, or vice versa. So n ki jagah, if I plug in 3, I should get 9a plus 3b plus c. And if I plug in 4, I should get 16a plus 4b plus c. So I've just written all the first four terms of any particular quadratic sequence, and I've generalized them. Let's look at the first difference between the first two terms. I'll just take 4a plus 2b plus c, and I'll subtract a plus b plus c. Remember, this is just a one-time drill. You do not always have to do this. So what do you end up with? 4a plus 2b plus c minus a minus b and minus c. So you'll end up with 3b plus c. Similarly, if I subtract the third term from the second term, the second term from the third term, 9a plus 3b plus c minus 4a plus 2b plus c. Again, the c's are cancelled out. See. The c's will be cancelled out and you'll be left with 5a. Sorry, यहाँ मैंने mistyping कर दिया. This will be 3a plus b, and in this one we'll be left with 5a plus b. And similarly, if we do it in this one, you can observe the pattern that must be 7a plus b. Now, what if you subtract the differences? जिसको difference का difference भी कहते हैं, difference of the difference, or let's call it the second difference. Okay, I'm subtracting the difference from the first one. So 5a plus b minus 3a plus b. So what should I get? B and B cancelled out. 5a plus b minus 3a minus b. So the second difference is 2a. Similarly, if I do it in this one as well. So 7a plus b minus 5a minus b. That should give me 2a. So the difference of the difference should always give me a. That is a very easy way to acquire your a. Once you get your a, you can choose any particular difference to get your b. The first one is the easier one. And once you get your a and your b, you can easily get your c from using any particular term.